Okay, here's today's notes, section 2.7. We're going to graph absolute value functions and talk about their transformations. This should be relatively easy for us because we've actually already done all the work, and we're just going to review this really quick. So if I gave you this function right here, you should recognize what the parent is, right? What's the parent?
Absolute value.
Absolute value of x. So let's, in order, talk about the transformations. And when I say in order, I'm talking about this order that we've discussed. C, A, then B, and then D. Okay? A and B are horizontal. Horizontal stretch or compression, and horizontally left and right, and C and D are vertical. Vertical stretches and compressions, and vertically up and down, right? So in order, what would be, is there an A value for this problem? No, we skip A. Let's talk about B. What's B? 1 unit to the right. What's the C gonna do?
Flip it.
Reflection over the x-axis. Is there another C value? Vertical compression by what? 1/2, and then the last thing. Up 3. Okay, so now, what we're going to do is look at the parent function. Here's your parent function right here. Okay. If we are going to shift this graph 1 unit right and up 3, let's look at B and D are going to be important for us. B and D are the big ones. If we go 1 unit right and up 3 right here, what's this point called, 0, 0? It's the origin, but do you know the special? It's the vertex. So what we did, B and D are very important to us in these equations. B and D. So what's our new vertex? If we
3, 1.
shifted 1 unit right and 3 up, what's our new vertex?
1, 3.
1, 3. So I want you to write that down. 1, 3 is your new vertex. Your axis of symmetry originally was the line x equals 0. What's our new axis of symmetry going to be?
X equals 1.
X equals 1. Do you know where it comes from? Yep, right there. X is equal to 1. Now, the only other thing you need to know for these absolute values, first of all, this graph is going to be upside down, so everyone should know that that's going to be shaped like that. See this number right here, 1/2? That's your slope. That's how you're going to go from this point. We're going to be going upside down. But think of 1/2 is you're going to go down 1 and 2 each way, down 1 and 2 this way. So think of splitting this into 2 equal parts, down 1 over 2, and you keep that pattern going, down 1 over 2, down 1 over 2. So you go down 1 over 2 in both directions. And then just draw your graph. This is actually, this is a compression. It made it fatter. It stretched it open. Okay, the general form for these absolute values is f of x. How did what? Okay, so did you get how do you get the vertex? Opposite of this, that. Negative 1 becomes a positive 1, 3. And then the negative means it's upside down. And then see this 1 to 2? I went down 1 and over 2. Down 1 over 2. Down 1 over 2. But because we have this axis of symmetry right here, we've got to go this way, down 1 over 2, and down 1 over 2 the other way. Okay? Yes.
Where did the first graph come from? That's where I'm.
The parent function that we talked about in section 2.6. The parent function, from here, if you were to plug in these numbers and take the absolute values of them, you get 2, 1, 0, 1, 2.
Yeah.
That's from
Alright.
last week.
Yeah.
Okay. Okay, so here is your general form, your standard form for this. F of x is equal to the a value, absolute value, x minus h, and then plus k. Where the h and the k value is going to be your new vertex. So I just want you to know that your stretch or compression is your a value, it's the absolute value of a. And I want to just say that B and D are they're the major parts, the two major parts of my graph, and that's going to give you your vertex. The vertex is the H comma K value, but your B and D are very important. These two are going to shift your graph left and right, the B and the D value, okay? So the axis of symmetry is the line x equals whatever h is, that's going to give your axis of symmetry. All right, so let's talk about, I'm going to concentrate on these two things. The vertex and the axis of symmetry.
I don't know how to end this. It was just I don't know how to end it. Oh, got it. I don't know what just happened.
We got that
We tried to
recorded too.
FaceTime me.
Yeah, you're gonna be on YouTube.
Okay, sorry.
All right, so check this one out. This is a strange one because there's something missing. Is the B or the D value missing? The B value is missing. It's x plus 0. Does everybody understand that?
Yeah.
So what is the vertex for this one? How would you say it? It's 0, 4. That's the vertex. Okay. What is your axis of symmetry?
0.
X equals 0. I need you guys to grab a piece of graph paper. Can you share? Pass those around.
Oh, it's just in the passing around.
Yeah, they got it back there. Pass the graph paper around.
Oh, you knew one?
So if we were to sketch this
Thank
graph, what would it look like? You're gonna need graph paper. Can someone tell me where to begin on this? Let's
0,
graph
4.
them. Where do we begin when we graph this? Start at 0, 4. Here's 0, 4. And is this upside down or right side up?
Upside down.
Upside down. So your shape should look like that, right? What's the slope? Make this a fraction. It's rise and run. So 2 to 1. So from this point, we're going to do down 2 and over 1. Down 2 and go the other way. Down 2 and over 1. Down 2. From here, go down 2 and over 1. So can you tell me?
Looks like a Christmas tree.
Huh? What?
I was saying, wow, it looks like a Christmas tree.
Looks like a Christmas tree?
Yeah.
Can you tell
Christmas
me
trees.
what is the x and y intercepts? 0, 4, that's your y-intercept, 0, 4. 0, 4. What are your x-intercepts? -2 and +2. So -2, 0, and 2, 0, if you're asked what the x and y-intercepts are. Okay? Everyone okay so far? Let's do the next one. This one's written to trick you. Can you fix it? Can you fix this? I want to know what's the A, what's the B, and what's the D value? The D is 0? No. Anyone know? It's 7. That's your D. They wrote it. They put the D value in front. They can do that. The D value is, I was gonna write D. D is 7. So what is your vertex, guys? What's your vertex?
0, 7.
Negative 3, 7. Negative 3, 7. What's your axis of symmetry? You take the opposite of this. Opposite, it's always been the opposite. Remember, you go 3 left?
Oh, yeah.
Okay, and x equals negative 3. And let's graph it. How do you where do you go? You're gonna go left 3, up 7. So let's go left 3, 1, 2, 3, and up 7. 1, 2, 3, 4, 5, 6, 7. Okay, now this one's upside down, right? It's the upside down is in front. It's gonna be shaped like a Christmas tree. I like that one.
Right,
Your axis of symmetry is going in between there, like that. And what's your slope? It's a 1-to-1 ratio, so you go down 1 and over 1 both ways. Down 1 over 1. Down 1 over 1. Oh, that's our y-intercept right there. Our y-intercept is 0, 4. And now to find the x-intercepts, we have to keep going down until we hit, and there it is right there. What's your y-intercept, or x-intercept? Is 4, 0. And to get the other one, you'd have to keep going. Anyone know what it is? It's gonna be, that's 9, and it's gonna be negative 10, 0. I'll keep going. Okay.
I'm like talking to myself.
You just like talking to yourself? Axis of symmetry is x equals negative 3. It's always this, the vertex, this number right here, always. Okay, flip it over. Okay, we are not gonna use, we're professional, we don't need a T-chart. We're beyond T-charts. Yep, let's graph this one. Number 4, tell me where to begin. Where's my new vertex? Everybody, where's my vertex?
2, 4.
2, 4. Put a dot at 2, 4. Everyone can do that. Over 2 and up 4, right there. Is my graph gonna be right side up? Is it a Christmas tree? No, not a Christmas tree. It's a V. It's a V. My axis of symmetry is x equals 2, right? That's my axis of symmetry. Where do I go to plot my next points? Up 3 and over 1. Up 3 and over 1. Now where do I go the other way? Is it just that right there? I gotta go up 3 and the other way, the other part of the V, right? Yep, it is. It's a mirror image. If you were to draw an imaginary line, they should be equal. This one side should be equal to the other side. Good?
Yeah.
Next. What if I give you a picture and I said, give me the function? Give me the, can you go in the reverse order now? What would you first want to find? What's that? The vertex, yes. Tell me the vertex. What is the vertex?
Negative 3, 3.
Negative what?
3, 3.
Negative 3, 3. Negative, so from here we went 1, 2, 3, 1, 2, 3. So, how do I insert the vertex into this problem? Well, I know I have an absolute value, something like that, okay, and I have, here's my x.
It's gonna be negative 2 because the graph is inverted.
Well, where do I put these two numbers?
The positive 3.
Good. This is gonna be a positive 3,
And then a plus 3.
and then the 3 outside, good.
You
Okay,
put a
now,
negative. Don't you put
Yeah.
a negative in front of it?
yeah, you put a negative out here, because it's upside, it's a Christmas tree. And now I need that vertical stretch or compression. How do I find out what number goes in front? What do I do? I wanna look at the rate of change here. What is this?
2, 1.
It's a, I see 3 to 1. I see 3 to 1.
I can't count.
3, you can't count. It's a
It's on
3.
YouTube, so.
Good? Okay, cool. Try number 6 now. Let's see if we can all get number 6. Here's my vertex. So I'm gonna write f of x. And this one is, I'm gonna put a 1/2 in front. Should I put a negative somewhere?
Nope.
No, it's not upside down. So think of the Christmas trees are the ones that are with the negative. Are you guys good? Okay, now, can you stop recording?